use this equation, and dot product with A1 over H, you will get the magnitude of N times the magnitude of A1 over H cos theta. Okay, and then the magnitude of N equal to 1 because it's a unit vector times A1 over H cos theta. So this is A1 over H. When you cos theta, you get this length. Okay, and this length would be the D3. You see that this length is actually the distance between these two lines. Alright, so therefore we can use N1 dot product A1 over H to get the distance between here, these two planes. So now, okay, we all agree that we can use this equation. And we know that N is a unit vector, means that the G over the magnitude of G. This is a very fundamental definition for the unit vector, right? So this unit vector, I substitute it into here. This one I substitute into here. So I will have G over G magnitude dot product with A over H. Okay, then G equal to this equation, or not this one, this one. Okay, and then you also substitute the magnitude into here. You also substitute the magnitude into here. Then you solve it, you'll get 2 pi over G. Okay, this is a simple mathematics, so I don't show here. You just take a piece of paper and then try to work it out. Okay, it's very simple. So we have proved that DHKL equal to 2 pi over G. The step is simple. You see, they just do a few steps. But why I spend so much time, because I want you to understand the concept why I use this unit vector of N dot product with A1 over H. Because this is just like what I explained just now lah. If you cannot understand, I would advise you to review again or rewatch again the video lah. Okay, because I understand that this is a little bit complicated, that you may need some time to understand it. Okay, now we proceed to the last question of this chapter. So for chapter 4, for question 4, I want to show that for the simple cubic, d square, the distance between two planars, equal to a square over h square plus k square plus l square. This is the reciprocal, and then this is the unit cell length. Okay, so for simple cubic, we know that DHKL equal to 2 pi over GHKL. We have proven it in the question 3. And then we also know that GHKL equal to H reciprocal A plus K reciprocal B plus L reciprocal C. Okay, so we start from these two. Therefore, we have 1 over D square equal to 2, okay, you just rearrange this equation lah. This one you got G equal to, okay, no, this is D what? You just 1 over D equal to G over 2 pi lah. Okay, you just square both, then get 1 over D square equal to G square over 4 pi square. Okay, because you only get D square, right? Then now, you substitute G square, this one into here. Okay, so you get HA here, KB here, LC here. Substitute here, then you will get H square plus K square plus L square over A square. Okay, the step is very simple. Okay, this is the step lah. Very simple. Okay, But there's one thing that you need to bear in mind is that A equal to B equal to C equal to 1 over A. The reciprocal A equal to 1 over real A. Only applicable for the cubic, simple cubic. Okay, if it's not the simple cubic, then you have to make use of this equation lah. Okay, you have to make use of this equation. But for simple cubic, you can simply say that A equal to 1 over A. Why? Because we have proven this just now, right? I have proven it. Why? For the simple cubic, the reciprocal A equal to 1 over real A. Okay, for simple cubic, you can do it this way. But if it is not simple cubic, then you have to use the proper relationship between reciprocal and real like this. Then you have to solve it. Okay, so since for this case, it's asked for the simple cubic. So you can simply substitute reciprocal A equal to 1 over A. Then after you solve it, this is a simple calculation, then you will get the answer. Okay, for simple cubic. However, if it's not for simple cubic, like for the orthorhombic is still okay because the degree is still 90 degrees, so not that difficult. For orthorhombic, tetragonal, and then orthorhombic, cubic, and tetragonal all involve 90 degree of the angle, then it's still easy. But if it's not 90 degree like monoclinic, it has beta not equal to 90 degree, hexagonal 120 degree or 60 degree, okay, 60 degree. Then triclinic, the angle are free, any angle. Then for these 4 crystal system, the cases, the answer will be much more complicated lah. So in the exam, normally I would just ask you to prove these 3, either orthorhombic, tetragonal, or cubic. If I ask this question, okay, I will not ask you the monoclinic, hexagonal, triclinic, and trigonal because I'm not going to test your mathematics skill. I want to test your understanding toward this solid state physics. I will not to test your mathematics skill. Therefore, I will only ask the orthorhombic. But of course, if you are good in mathematics, there's no issue for you to derive the monoclinic, hexagonal, and triclinic relationship. Okay, I think that's all for this chapter, and I'll proceed the next chapter after this. All right, thank you.